Hello students, hope you are doing great. Today we'll start with external interrupts. On this topic we have to finish, and here in external interrupts corresponding to LPC 1768, we'll understand the pin configuration as usual with every thing related to the kit. We understand the pin configurations. So that pin configuration we will understand. Later on, the register sets which are involved in configuring the corresponding pins as external interrupt pins, that we will understand that how many registers are involved. Apart from that, we'll understand one program in which the external interrupt we will use to toggle the LEDs, which you can use for any purpose. Prior to discuss the interrupts in detail, I want to discuss that how, if you don't have to use the interrupt, how we have made good use of the external input. So as you can remember and recall, the external switch was available in our kit, LPC 1768 kit, which we are using for our lab purpose. So there, the external switch we have used for providing external input to one of the pin. That pin continuously our processor was in search of whether it is 1 or depending on whether level 0 or level 1 will occur over that pin. So based on that, then our processor has taken actions. But problem with that sort of functionality is that your processor has to continuously actively look for the configuration or the pin configuration or the pin value of that particular pin. So to get more into the detail, so here if you can see, so I will share my screen. So I hope that now you can share or you see this program. So here in this program, our purpose is to use the pin 1.29 for LED purpose. So that pin is directly connected to LED, and that we want to toggle just. And we want to do it once our switch, and that switch we have configured as means connected to our port number 2 and pin number 0. So that pin continuously being checked here. So if you can see here in this if condition, we are continuously checking the pin. If this is 1, then only we are coming inside the loop and doing our operations. So in this regard, we are continuously using the system resources. And when you are using the system resources, so it is not an efficient way because we don't know when user will provide that input. User can provide that input without delay, or user can take as much delay as possible. So we don't know how much delay is going to be prior to you go inside the loop. And prior to that, still your process is continuously on. So in that situation, if you want to tackle, so we know the interrupts comes into play. You can use interrupts for that purpose. How you can use the interrupts? Now here we will use, instead of this if condition, we will use some external interrupt. That external interrupt pin. So obviously some pin we have to configure as an external interrupt pin. That system will take care of it. You don't have to write that thing in your code. So system will take care of that. So for that purpose, there's a system controller, and the name is NVIC. That's controller name. A nested vectored interrupt controller. Interrupt controller will take care of all these things on its own. We don't have to worry much about that. And how normally the interrupt routines work. So for that purpose, we will understand the interrupt sharing routine. So here in interrupt sharing routine diagram, so here is our diagram, as you can see. So we have 4 external interrupts. So at a time, 4 external interrupts can be handled by our LPC1768. So for corresponding to 4 external interrupts, you require 4 pins, and those pins you have to configure as input, means external interrupt pins. So we'll understand that how to configure those pins. So anything to configure, anything to deal with configuration, we have to deal with pin configuration registers. So pin configuration registers we have to configure for making those corresponding pins external interrupt pins. So once you have configured those external interrupts pin, your LPC1768 interrupt controller, NVIC controller, that controller will look for any external interrupt. As soon as the interrupt occurs, it will hold the normal operation, whatever the normal operation is going on. It will hold the normal operation. Then it will look for the vector address or the vector table, the address table corresponding to that interrupt service routine, or how to handle it. Obviously, once the interrupt occurs, your system should know that how to handle this. To handle that, somewhere you will write in the interrupt, so that we have to write that what exactly we want. Once the interrupt handler will take care of it, once after normal operation you want to interrupt it, so after interruption will take place, so what exactly you want to do. So for that purpose, your interrupt service routine will take charge. So interrupt service routine, after completion of your code corresponding to the interrupt, then you will resume back, your system will resume back with normal operation. That is the simple in layman understanding of the interrupt. And now we have different types of interrupts. So these interrupts we are handling as in hardware interrupts. Some software interrupts are there also, as in every language, you know the concept of interrupts handling. So those are called software interrupts. Some are nested interrupts. So here the possibility means what is the meaning of the nested vectored interrupt controller, why the word nested is there. Nested means when you are already in interrupt, so within interrupt, another interrupt is possible. That is called nested vectored interrupt controller. So that is a controller, but what is the meaning of nested vector is that within, at the time of interrupt, another interrupt is possible. So that corresponds to our external interrupts, means external software interrupts and hardware interrupts. So vectored interrupts, non-vectored interrupts. So here we will use the vector interrupts, means the address is there where interrupt service routine will take the operation and then resume back with the normal operation. Now we will understand our LPC1768 external interrupt. And after understanding this, we'll go through one program in which we will toggle one LED based on interrupt. We will toggle two LEDs, so two external interrupt we will use. So two pins we will use, and based on whenever the interrupt occurs, whenever we'll press the switches, whenever we will give the external hardware interrupt, so corresponding operations will happen. So in LPC1768, as we have already discussed, I have already mentioned that we have 4 interrupts. interrupt 0, the naming convention is external interrupt 0, EINT 0 to 3. So 4 interrupts are there. Now, corresponding to 4 interrupts, obviously we require 4 pins, which we can configure, and then your system can understand that these pins are for external interrupts. So these are fixed pins. So these pins we will configure using pin configuration, pin select registers. So port number 2 will be used for that purpose, and particular pins 10, 11, 12, and 13. These pins are going to be used for external interrupt. So these pins, as we know, these pins can be used for external GPIO purpose. So that is the function 0. So if we want to use it as function 0, so obviously in pin select register, which pin select register we will use here, because it is the second pin, second port. So pin select 0 is for port number 1, pin select 1 is for port number 1, pin number 16 to 31, and then 10, 11, 12, 13. So pin select third register we will use. So pin select third register, and in third register this 10th pin we are using, so which every pin will use 2-bit position. So port number 2.10, 10 will use bit positions 20 and 21, 11 will use the bit position 22 and 23, 12 will use the bit position 12 to the 24, 24 and 25, 13 will use 26 and 27. So if you will write corresponding to those bit positions, so the pin select function once, that is 0, 1. So then in this way we can configure those pins as external interrupt pins. Then no more those pins, because if you will not write anything, the value would remain be 0, 0. That means those things will work as general purpose input output. But if you will configure that as 0, 1, that means corresponding pin later on will be acknowledged by the system as external interrupt pins. So that's how you can configure those pins. So as and when you have to write any code and you have to use external interrupt, so in that sense you can use either pin number 10, 11, 12, 13, any one of these pins, depending on how many external interrupts you have to work with, and the port number 2 and the corresponding pin select register. So pin select third register we will use for that purpose. And so already we have understood the concept of interrupt service routine. Then these are some of the registers. Already one of the register we have seen, the pin select register. So pin select register will be used for configuring the corresponding pin as external interrupt pin, so that later on, from then on, the system can acknowledge it as an external interrupt pin, not as GPIO or some other function pin. Then you have external interrupt pin. So one by one we will see. External interrupt pins are 4 in number. Corresponding to each interrupt, we have external interrupt pin. So interrupt flag for interrupt 0. So sorry for that. External interrupt is only one register. So 4-bit positions of the same register we will use for our external interrupt. So as and when system would acknowledge, would register any interrupt, so that registry will go to these interrupt flags. So these are the external interrupt pins 0 to 3. So 4 external interrupts are possible. So as and when system would acknowledge any interrupt, so the task of the system is to write 1 corresponding to that interrupt. So if over the interrupt 1 pin, suppose interrupt occurs, so the task of the system is to make this corresponding bit position as 1. So this position will be 1 later on. So these bits, so these bits, 4 bits we are using for 4 pins. So as and when any system would acknowledge or register any interrupt over these things, so that is called clearing the interrupts also, or registering the interrupt also. Anything you can understand. How to clear the interrupt? So if you have to start with new program and you are not sure whether any already interrupt been acknowledged there or not, so in that sense, in that situation, whatever the interrupt, external interrupt you are using, corresponding to that bit position, make that bit position as 1. That's amount to clearing that interrupt. So 1 over 1, that's amount to clear over the interrupt. Because then we have external mode. So obviously we are using pins, so we will use signals for acknowledge or the interrupts. For that sense, when you are using signals, so the level, those signals, those interrupts could be level triggered, signal level could be the point of understanding or acknowledging the interrupt, or rising or falling edge. So edge triggered interrupts can be the possibility. To do so, we have external mode. So here we will define the mode on which we will acknowledge the interrupt, whether the interrupt would be acknowledged on level of the signal or on the edge of the signal. So 4 interrupts are there. So corresponding to every bit position, we have the corresponding acknowledgement mode. So if 0 is there over that bit position, that means it is level triggered. If 1 is there, that means it is edge triggered. So this configuration is essential, because if you will not configure it, system will never be able to figure out, or even if you will not write anything to the external mode, it would be level triggered, because the value would remain be 0. Then once you have defined it, suppose it is level triggered or edge triggered, then the next situation arises, and that is the polarity. That means, suppose you have defined the mode that is level triggered. Now there are 2 possibilities: whether the positive level would be considered as acknowledgement or acceptance of anything as an interrupt, or negative level would be considered for that matter. Likewise, if you have configured something, means mode as edge trigger, so 2 possibilities are there. Either the signal can rise, so rising edge may be considered as acceptance or registration of an interrupt, or the falling edge could be taken as an acceptance or acknowledgement of an interrupt. So for that purpose, there is one mode register, and that register would always be read in accordance with the external mode register, because if in isolation you will understand the external polarity register, it has no meaning attached to it. So always in consensus, or always in understanding of the external mode register, we can understand, or we can make some meaning out of external polarity register. So in external polarity register, likewise, because we are dealing with 4 interrupts, so every bit position corresponds to that external interrupt. And so the 0 means corresponding to the mode. If the mode is level, 0 means it is active low. If the mode is 0, that is level triggered, then 1 means active high. So, and likewise, if you are using edge, so 0 means falling edge, and 1 means rising edge. So that is the general notation attached to these registers. So once again, for your reference, I'm mentioning the registers. So first one is to configure the corresponding pin as an external interrupt register. So pin only means these are fixed pins. Any pin you can't configure as external pin, external interrupt pin. So pin number 2.10, 2.11, 2.12, 2.13 can be used for external interrupt. Then once you have configured those things, later on, external interrupt. So system would acknowledge that as and when any interrupt occurs, so system would acknowledge that interrupt in external interrupt register. So external interrupt register out of 32, we are using the initial 4 bits for our 4 interrupts. So if any one of these is 1, that means it's been acknowledged, and if the corresponding pin we have configured as an external interrupt pin, then ISR interrupt service routine would take charge once we have acknowledged the interrupt. Now, how to acknowledge the interrupt? Because these are external hardware interrupt. So obviously we are dealing with signals. So once you will attach those pins with any external switch or any external peripheral which will provide any signal over those pins. So once suppose we have attached that pin, suppose we are using the external interrupt 0, so we are using pin number 2.10. So pin number 2.10 we have to attach with either the external peripheral which will generate on our behalf an interrupt, or any switch we can consider for that sake. So suppose the external switch we have attached and connected to pin number 2.10. So once you have done it, and now when you are pressing it, so then obviously you are generating one signal. So that signal will go over that pin. So now based on the level triggered or edge triggered, system would consider it as an interrupt. Once you have defined that thing through the external mode register, in understanding of the external mode register, external polarity register we have to see, and we have to configure it. So whether if it is level triggered, whether the positive level or the negative level would be considered as a triggering point or would be considered as an interrupt occurrence, and likewise the falling edge or the rising edge. So these are not so many registers to remember. So once this is already synced in you, I hope that now you can understand the procedure, that how we will actually go about writing any program. So first and the foremost thing is the configuration of the pin. So here you will configure the pins first. So pin select, I think the third register we'll use, because pin 2.10, 11, 12, 13. So I think pin select third we will use, and it is the function 1. So always we will write 0, 1, 0, 1, 0, 1, 0, 1, depending on which external interrupt we will use. Once that is defined, then we will clear the already pending interrupts. So how to clear it? We'll simply write 1 over the external interrupt register. Then we will define the mode. Once you have defined the mode, whether we will use the level triggered or the edge triggered, once we're done with the configuration of external mode register, then we will go to the polarity definition. Once it is done, then in the program, we require one interrupt handler. So whatever we will write in the interrupt handler, that would be considered as an interrupt service routine. So whatever you will write, so in the normal operation, as in when normal operation is going on, and when you will provide the external interrupt, as and when the external interrupt occurs, then your normal operation would be halted, and your interrupt service routine would take charge. And obviously after completion of the interrupt service routine, so whatever in the interrupt handler we will write corresponding to any external interrupt, so there would be one external interrupt handler. So that external interrupt handler would comprise of the code, which would be nothing but the interrupt service routine. and we have to enable it. So prior to, so in our code itself, we have to enable that interrupt. So to enable any interrupt, so always we will use this function nvic underscore enable IRQ, and as an argument we will provide that interrupt name. So with IRQ number or the name. So here is a simple code. So here we have to toggle two. Here in this code we have to toggle two LEDs. So two LEDs we are using. So those two LEDs will connect with any two pins. So pin number 2.0 or 2.1 we are using for that purpose. So 0 and 1. So port number 2 we are using. And why this 20? So these are some defined macros. So 20 and 22, because we are using pin number 2.10, pin number 2.11. So corresponding to pin 2.10 is external interrupt 0. Corresponding to pin 2.11 is interrupt 1. So interrupt 0 and interrupt 1 we are using. And when we are using those interrupts, so we have to first configure those two pins as external interrupt pins. So to configure those two pins, bit number 20, bit position 20 of pin select third register should be 1, because it is 0 1 0 1. So for that purpose 20 and 22, and these are two LEDs which will keep on toggling. So we'll toggle those two pins. Pin 2.0 is connected to LED 0, pin 2.1 is connected to LED 2, and then these are some more macros for external interrupt 0, external interrupt 1. So for those two external interrupt register, so these are the macros. So to for definition, for defining or the configuring external mode, these are the macros. So because 0 is why? Because we are using external interrupt 0. So these things will be used for putting exact value which we want to write in that corresponding register, external mode register. So we want to deal with 0th position and the first position. Likewise, 0th position and the first position in the polarity also. So here is our interrupt handler. So the name convention we have to follow. So interrupt 0, likewise interrupt 1. So IRQ handler. What exactly we are doing? As in when you will receive an interrupt, system will receive an interrupt, so system would send it to interrupt service routine. Whatever we will write inside this would find its place in interrupt service routine. So as in when you would receive an acknowledge, means acknowledge any interrupt, what you will do, you will first clear that interrupt flag. So in external interrupt, whatever be the value right now, you would overwrite it with 1. That amounts to clearing the interrupt. That means you have acknowledged the interrupt. Then after that, simple operation you are doing, GPIO 0 FIO pin. So here you are XORing it. So whatever be the value you want to, just toggle it. So 1 LED 1. So what is the value of LED 1? LED 1 is 0, means the 0th position, P2.0. That pin we are using for connecting with LED. Then likewise in interrupt, exactly the same thing we will use. So external interrupt, but here this time, so here you can notice 1 you have shifted how many times, because it corresponds to interrupt 0. So we're not supposed to uh, left shift it by any time. So SBIT, so this value is 0. Hope you can understand it easily. Likewise in interrupt 1 IRQ handler, you can understand it quite easily. Here also we are toggling, but here we have connected P2.1 pin. So that's why LED 2, P2.1, and here external interrupt 1 we are using. So that's why this value is 1. So 1 shifted by 1 time. Now in the main function, system initialization. Here in our kit, we don't require this function to write. And here you can see, so first you will clear all the pending interrupts. So in the main program, so once you start your routine, so first you will clear all the interrupts. So we are using two interrupts, interrupt 0 and interrupt 1. So 1 we will write over the interrupt. So interrupt 0 value is 0 and this is 1. So over the position 0 and 1 we have written 1 1, that amounts to clearing the pending interrupts. Then we want to configure our pins as interrupt pins P2.10, P2.11, 12, 13. So here I feel that this should be 3 because it is P. No, it is correct because port number 0 require pin select 0, port number pin select 1, port number 1 pin select 2, pin select 3, and port number 2 pin select 4, right? So pin select 4 we will use, and what exactly we are doing, the 20th bit and the 22nd bit we are making 1. So if you will make it 1 means 20 and 21 will be 0 1. That means you have configured that pin as external interrupt pin. Likewise 22 and 23rd, once you have made both pins as 0 1, that means it amount to configure that it as external pin. So here we are doing nothing but we are configuring the corresponding pins as external interrupt pins. Here we are configuring the pins as, already we have configured it. So here we are defining the mode. So here our idea is to make it edge triggered. So 0 means level triggered, 1 means edge triggered. So 0 times we have shifted for external interrupt 0. 1 we have shifted 1 time to make the external interrupt 1 as edge trigger. Likewise, once you have defined it, then you have to define the polarity. We want to define the polarity as falling edge polarity. So 1 shifted by 0, 1 shifted by 0. Simple to understand. Then once you have defined it, so corresponding to LEDs, because LED pins would be connected to LEDs directly. So those LEDs would be used as an output pin, because system would put corresponding toggled value over those output pins, and those output pins are connected to LEDs directly. So here you are defining the direction. So writing 1 over those positions in FIO direction register amounts to set the direction. So 1 means output direction, 0 means input direction. So here 1 for LED 1 is 0, 1 for 0. So in FIO DR direction corresponding to GPIO 2, we have set the direction as output direction. So here initially we have set all the pins as zeros when nothing is on, and here we are enabling the corresponding interrupts. So once you have enabled it, both we have to enable. So NVIC enable IRQ. So this function is same, but argument would differ because we are using interrupt 0 and interrupt 1. So we have to enable both the interrupts. And then we are doing here in the while loop nothing. So your program would always continuously be in this loop. And here in whole program, as you can see, we are not continuously checking any external interrupt pin. We're not checking it. NVIC would acknowledge our interrupt. Once your controller, the nested vector interrupt controller, would acknowledge your interrupt, because already you have enabled 2 interrupts, so it could acknowledge only 2 interrupts. it would not acknowledge other interrupt, even if you were to connect your pins. But until and unless you would configure those pins and enable those interrupts, so your interrupt controller would not acknowledge those interrupts. Once you have done it, uh, everything is done. So if any one of these two interrupts you would provide to the system, then what system would do, it would halt to its normal operation. So what is the normal operation? Continuously be in this loop, that is the normal operation. So instead of that, what system would do, suppose if you will interrupt 0, so interrupt 0 is enabled. So once you enable the interrupt 0, so the system would take you to its handler, that means interrupt service routine, and first it will acknowledge that interrupt in external interrupt register. How it would acknowledge the interrupt? By setting that value as 1. Once it will set the value as 1, uh, once it will set the value as 1, then you're just toggling that FIO pin, which is directly connected to LED. Likewise, if you will enable the interrupt first, same operation will happen, but this time pin is different. That's it. Hope you have enjoyed the video, and so yeah.